I welcome you all dear friends. Welcome back. We are learning some techniques to solve some of the simple harmonic motion problems. And we are up to the 11th problem of this topic, that is simple harmonic motion. Here is what we are required to find: the amplitude, frequency, and time period of an object oscillating at the end of a spring. If the equation for the position, if its position at that instant t is basically this one is the equation. X is equal to 0.25 cos pi by 2t, pi by 8t. Find the displacement of the object after 20 seconds. So here is the problem. X is equal to point. This is basically the equation. And we know that instantaneous displacement in simple harmonic motion is x is equal to x naught cos omega t. And this x naught is given. It is 0.25. Omega is pi by 8. So the amplitude is basically equal to 0.25 meter. Maximum displacement to either side of the mean position. So user has to calculate frequency. Frequency is omega divided by 2 pi. Basically time period is equal to 2 pi divided by omega. Take the inverse of the time period. Here it will be. So if you put the values, you are getting 1 over 16. And this is the frequency required to calculate after these given values. So if you look at, here is the displacement, here is the equation, and the given equation, and this is the equation for instantaneous displacement. Comparing 1 and 2, you get x naught is equal to 0.25 meter. So from this equation, you have calculated basically this amplitude, and then you have calculated frequency. Frequency is inverse of time period. So I have been proceeding further. This frequency is basically omega divided by 2 pi, and after putting it is 1 over 16 hertz. And what is time period is inverse of the frequency. Take the inverse of 16, it is 16 centimeters. 16 second time period. Simply if you calculated frequency, you will take the inverse of the frequency, you will be able to calculate time period by taking the inverse of frequency. Now, if t is equal to 2 seconds in equation, then we get putting the 2 in the t and putting the other values of the given values, that is 0.25 cos pi by 4. Cos pi by 4 means 180 divided by 4. After putting the values, you are getting displacement. It is equal to 0.25 multiplied 0.707, and this displacement is 0.18 meter. So here were the few steps which we have calculated. The equation given is this one. You were asked to calculate amplitude, frequency, and then you have calculated the displacement, and you have used this technique or this formula by putting the value of frequency and taking its inverse to find the time period, and then we have put the value in the given equation, and finally we have calculated the displacement. So with this, today's topics end. I thank you very much for your attention, and I hope you people have understood how to solve some of the problems of simple harmonic motion. I thank you all for your attention.